that. Yeah. So first this one, you can use the link command. Given ranges, return true if each integer in range left right is covered by at least one interval in ranges. An example, everything from 2 to 5 is covered by those, and constraints are very low. So easy solution is just some implementation of that, where let's say we can have a set. That's easiest to do. For every range in ranges, let's iterate over this range. It goes from this to that, from L to R, and go through that range as insert I. Now S contains all integers that are covered by the ranges. For everything from left to right, we want it to be there. So if S count of I is not 1, if this is 0, then that's bad, this number is not covered. And done. I think it's a good warm-up problem. Hi Samrat, Lakshay. Competitive programmers are so cool. Well, I guess. This problem was much harder than the problems usually on LeetCode. Maybe you mean the first problem in the contest? I don't know. I think it's similar. It's just like other easy problems in LeetCode, right? We can also think how to speed this up. Insert operation here is logarithmic. We can make it constant if that's unordered set, at least expected constant. Or the really faster version would be to make this into a Boolean array to cover just elements from left to right. If we want to cover elements from 10 to 15, then we need a Boolean array of size 6 to cover those. That will be most efficient. Of course, we can have an array of size 16 with indices from 0 to 15, but this would be better to represent this with an array with indices from 0 to 5. So really what you would want to do for speed, if constraints were bigger, but that's not optimal, is to make something like this, say present or exists. Exists is better. Of sides right minus left plus 1. That would be 6 if left and right were 10 and 15. Like that. And here, if I is in this range, then we should mark exists of something as true. And this something is I minus left. For example, if left is 10 and the right is 15, left 10, right 15, and let's say we have I equal to 12, that will be here at position 2, because if I have an array just for values from 10 to 15, then 10 should be at position 0, 11 at position 1. In general, I is at position I minus left. Now if we have any false value, we can even iterate like that. If anything in exists is false, return false. This is much faster than anything like a set or an ordered set, just because an array of bools is very fast. Don't worry about this runtime, this is all anyway fluctuations. Just there's overhead of running a program, and this time isn't measured perfectly. And if you want to make it much faster, then and just better complexity because it will be linear, then you should use prefix sums, rolling sums, something like that. And then you will be able to solve the problem Like here I have quadratic time. For every range, I go linearly through that range. So instead of the current, the number of ranges times size of range, we will get down to R plus range size. That would be the speed up from prefix sums. So by R I meant ranges.length. And range.size is size of a single range, so limited by 50 here. And that answers question by Tarek. Yeah, it can be done in linear time. Prefix sum is best. It solves this problem, but during a contest, if I cared about the time of coding this, I would just use set like I did at the beginning. Then you don't need to worry about indices, for example. Regarding this comment, what if you sum the numbers? That's not a good idea because some numbers can be repeated. From 2 to 5, you can expect the sum like this, right? And you can check, well, if I get sum, not 11, what's that? 14. If you get sum of 14 of those numbers in the input, then yeah, you say that you got the proper sum. But some numbers can be repeated. What if the ranges actually will cover, let's say, 3, there will be a range from 3 to 4, that's 7, and say another range from 3 to 4, that's another 7. This in total would give you 14, but not all numbers are covered. If you want to check if everything is present, the sum doesn't say that, unless you have a guarantee that nothing is repeated. But if nothing is repeated, then you can as well count. Getting the sum of values is useful if you know, for example, that one of them is missing. If you know that you're given all numbers from 1 to n, and one of them is out, then sure, sum all of them up and see what value is missing to get the full sum. Struggle in ad hoc and problems which needs complex looping. How can I improve? As always, by solving problems. There isn't anything like you improve by learning algorithms and by solving problems. That's it. There isn't any hidden trick. Now moving on and getting some suggestions. Minimum cost to change the value of expression. Two people already suggested that. I can consider this. Super egg drop. Super egg drop is covered a lot on YouTube. I won't be surprised if even I covered it. I don't think so. First live stream. Hopefully not the last one you watch. You give it a valid Boolean expression with characters 1, 0, and or, and brackets. This is a valid expression. Return the minimum cost to change the final value of the expression. Do we go? Oh yeah, left to right. I wanted to know this. We go from left to right. So really, if we have this thing, then I can, I think, as well insert some brackets to say that, well, first we handle the leftmost operation, then the second leftmost, and so on. So I can assume that really I insert some extra brackets. Also, let me give you a link. Done. I think I will not implement this one. I for sure already did it multiple times during my streams. I guess I need to organize streams in some way so you could easily find a problem. We'll think about that. So yeah, let's assume that just there are brackets everywhere, and we need to change value of expression. This problem is super hard. Well, let's see. There is always, no matter how complicated the expression is, there is that most important, let's say the main operation, like here AND. There will be some stuff computed here and there, and eventually we will get here an AND. This will be evaluated to something, maybe let's say 1, and the right part will be evaluated to something, maybe 0. Here, if we have 1 and 0, if you want to change this value, for sure you need to change this from 0 to 1. So you can recursively go to this smaller part. But what happens like here? If it's 0, 0, then if you want to change the value, you need to change both, 1 and 1. Like, you need to change this from 0 to 1 and this from 0 to 1, only then you will get 1 and 1, so in total the value will be changed. If it's 1, 1, then you can change either left part or right part, and then the value of the whole expression will change from 1 to 0. There are various situations, and like here, in this case, we need to change either the left expression or the right one, whichever takes fewer operations. Which means that for both parts, I need to say how many operations I need to make here, or how many changes rather, in order to change the value. And that will be it. So it's like, let's say, kind of dynamic programming on a tree, because you can make a tree out of this Boolean expression. Need to draw something. The code will boil down to implementing a recursive function. It should be quite fast. Implementing a recursive function that will evaluate this expression, and as it goes, for every smaller part, not only it should say what's the value, but also what's the number of operations to get the other value. So it doesn't just return bool. It returns two values, bool, comma, int. How many operations are needed? Can you please implement? And I think it would take a lot of time to implement this. What do we have? We have, let's say, 1 and 0, or 1 and 1. Let's say this is our expression. Then we can make a tree out of it. The main thing is OR. Maybe I will use a word for that. There is OR between left expression, which is this one. It takes AND of 1 and 0. The right expression is AND of 1 and 1. The leaves are values. Each value is 0 or 1. Then what happens for this subtree? For this subtree, we know that its value is 1, because 1 and 1 is evaluated as 1. Let's say true. Comma. What's the number of changes needed to change this true into false? We need one change. Because changing from 1 to 0 is enough. What about the right tree? There is value false here. I think it will be more interesting if I change this from 1 to 0. Let's say it's like this. Stupid keyboard showing up. Let's say this is the expression. Then the value of 0 and 0 is, well, 0, so false. But if you want to make it into true, you should here actually change two values. And now always when two subtrees will tell you their values and their number of required changes, and now you have the total thing, like here or, you can in constant time say what happens for the whole tree. What happens here? False or true, that's true in total. This is now for the full tree, so I'm saying what happens for the whole tree. The whole tree or whole expression is evaluated as true. I just took OR of those two expressions, those two values. And what's the number here of changes needed to we need to apply to change from true to false? So what's the answer for this full expression? And what's important in dynamic programming on a tree is that now we can forget completely, and by completely I mean let's literally erase it. We don't have any access for that. I just know that on the left there was something evaluated to false, but with two operations I can change it to true. On the right there was something evaluated to true, and with one operation I can change it to false. If I have OR of that, I get true, and if I want to get false of that, of this thing or that, what do I need to change? Well, obviously this guy. This needs to be changed to false. So I here rewrite whatever number was there. I don't even care about this guy. If I have false or true, and I want to change this value from current true to false, I need to change the right value. I don't care about the left one. Changing the left one from false to true doesn't help. So here, as I said, because we need to change the right thing from true to false, I will rewrite one, this guy. This problem is about a series of ifs to make up the whole logic of depending on what is here and what do we have in the two children, two smaller subtrees of this binary tree. We will have some value there. That's it. I think it can be handled without ifs, with some multiple for loops of size 2. Yeah, but as well you can do ifs. What if the original string isn't formatted correctly? Yeah, what then? If you're asking whether we can check if string is a valid Boolean expression, then yeah, and for sure there is a problem for that in LeetCode. If you say that there is given an arbitrary string and we need to count the number of changes needed to change it into a valid Boolean expression, it's a much harder problem, and I don't think it can be solved for these constraints. It will be some interval DP, where it's like how many changes needed for this interval to make it a Boolean expression. Yeah, Peter assumed that that problem is just very, very hard. Thanks again for getting a job at Amazon. Well, you're welcome, and again, congrats. How to get dark mode in LeetCode? There is just Google any kind of extension. It's called Dark Reader, my extension. Chrome, it's Chrome extension. A lot of viewers from India? Yeah, there are a lot of programmers in India. In Code Forces, half of participants are from India. If you look at any biweekly standings, half of participants are from India. So same in my audience, half of viewers are from India. Right, I'm not implementing this because it's standard if you need it. If not, you need just a lecture on how to handle recursive expressions like this one. Okay, let's continue. Please try this from Kickstart. I'm not solving Kickstart today. LeetCode largest magic square Q3 in today's contest. What is the timing of contests? LeetCode. I should have participated today. It would be perfect to, just after the contest, make a stream discussing problems. Yeah, that's bad. Or maybe next time I will just do a virtual participation directly after the contest. It lasts hour and 30 minutes. So, oh, then I didn't realize. It ended just before my stream, right? Yeah, that it makes even more sense to participate. I should have done that today. Well, next time. It's once every 2 weeks. There's also a weekly contest. It's 4:30 AM. Quite late and quite early for me. In your explanation, you can also change the root node to end from or. Can I? I didn't know that. I can. Oh, thank you. I misunderstood. I thought that we can only change zeros and ones. Yeah, but it doesn't make the idea more difficult. Here, I will also consider that with one operation I can change or to end. I wonder if then maybe it's always possible to handle that with one operation. No, I don't think so. Is there a sample? Yeah, there is a sample where output is 3. No. So if we can also consider changing this to end, we see if then maybe the value false and true is different from false or true. In this case, it is different, so one operation is enough. But there will be cases where changing this from or to end doesn't help. But we should then consider maybe changing one of the values, like maybe this guy, from false to true, and changing from or to end, stuff like that. With ifs, it is plenty of work. It can be automated for sure, a little bit. I will try something like this, where there's left part, right part, and the middle. For let's say that there is value of left. I'm not going to implement the whole solution. This is just how I would handle the merge, that main logic that we could theoretically do with plenty of ifs. For left, for let's say operation, you can do this in C++ to iterate over 2 values. Over operation as well. Operation, let's say 0 for OR and 1 for AND. By default there is something there. So let's say if default value is different from get value with left, right and operation. Left stands for true or false, what I want to have on the left. Right, same for the right, and operation says whether operation is or AND. Now, if default value is different than that, then required minimize with here whatever is needed to get this. By default, required is infinity. Int max will be fine. What's here required? I need to say what's the cost for my left child to be changed into this. And I will have some, this will be inside DFS. This DFS will return, I think, 2 values. What I'm evaluating to and what's the number of changes needed to get the other value. Of course, if this is a leaf, then I will do something special, but I will remember what happened for my left child and for my right child. And here in dots, I need to use those to say what's the cost of changing to this value on the left. It's more or less this. Cost is 0. If left, the value I want to get on the left, is different than left child dot first, than the value that is there by default, then I add the cost that is needed to change the left value. Same for the right. And if operation is different than operation here, I don't know how we store that, then cost plus plus. This means changing between and or in this place. Like that. This is required, and required is now the minimum cost to change the whole expression here, like to change expression to flip the value between false and true. And we return a pair something comma required. What's something? Oh, that's not really good. I should say, oh yeah, if default value is different than this value. Here, yeah. Make pair, and this is the value I'm evaluating to if I don't change anything. So this should be get value of whatever my children returned as first. My left child dot first is whatever is there by default, if I don't change anything. Oh, and that's called default value already. So default value is what happens if I don't change anything. Default value is get value with whatever my children give me, and operation here. This should be taken from the input in some way first. This is what we can do if we first, with some recursive parsing, if we process this, if we know what's the binary tree, we need to parse this thing. And there are problems for that in LeetCode. You can practice, like how to implement basic calculator. Won't this lead to time limit exceeded? Well, this part is linear. It's just DFS. So visits every node once, and there are n nodes. There's linear number of nodes. Every node in this binary tree is for one operation, and or. Do I watch Euro 2020? Not really. Let me know your desktop wallpaper. I don't know. Either it was default on Windows, or maybe I googled dark Windows wallpaper. Please try this. Another house robber problem. Big O of DFS is linear. It's O of number of nodes, because every node in a tree you visit once. And that's O of here, well, length of this expression. Expression.length. Because every node corresponds to one operation from the input, or AND. But this goes after first, also with recursive parsing, we actually understand the structure of the input, and I would say that that part is harder in linear time. DFS n plus m, for binary tree, number of nodes and edges is the same, at least complexity-wise. In binary tree, number of edges is number of nodes minus 1. So I can say that actually for any tree, in a tree, the number of edges and nodes is the same, so you don't need to specify the number of edges. Watching stream on both platforms to understand in 2 times the speed. Good. Also open it on your phone. Why am I not using IDE? I'm using IDE. Isn't this also IDE? Anyway, I didn't want to implement the solution here. I only wanted to write this, let's say, pseudocode. Actually, it turned out to be just code. But there is that tedious and boring part of parsing. So what does IDE stand for? It needs to be an app, not in a browser. Next problem. Hi, Abdullah. Daily problem. LeetCode still does daily problems. Integrated development environment. Well, this thing is integrated into LeetCode. You can argue if it's for development. So yeah, I think it matches this thing. It matches the definition of IDE. House robber free. Let me see what's house robber free about, but I did some house robbers in the past. I wanted to hit submissions to just see if I solved it, not really solution. Where is Gene integrated then? Yeah, it seems that something like this is more integrated than an app offline. I will read the statement and then decide if it's worth it. Each house has one and only one parent house. You cannot break into two neighbors. Yeah, this is cool because it's related to this problem. It will also be DFS on a binary tree, so we should solve it. Yep. Thank you for your suggestion, Tanay. It's a good thing if the problems are not completely unrelated to each other. The thief has found himself a new place for his thievery again. There's only one entrance to this area called the root. Actually, is that important? It's just definition. Basically, they say everything is the tree. That's it. You're given the root. Each house has only one parent. There will be police contacted if two directly linked houses were broken into the same night. Maybe he should then just break into everything on 2 consecutive nights. One night he could do every even layer, and next night he should do every odd layer. Easy. Given the root of the binary tree, return the maximum amount of money the thief can rob without alerting the police. Have we moved from the previous problem? We just have. Yeah, this is a new problem, but I've read the statement, that's it. Nothing more happened. Every dynamic programming tree problem, almost everyone, has the same structure where we... What happens? You look at a particular node. Maybe it's not the root, but let's say for a moment it is the root. There is here some left subtree, some right subtree, and you run DFS. And you hope, yes, I'm trying to fit it not to cover anything. You want this DFS to return something when you exit from the left child, when you exit from the right child, some value. Like in the previous problem, that DFS returned a pair. What value we have, well, true or false by default without changes, and what's the number of changes required. Here, some first idea will be that for this subtree we return what's the total amount of money we can get. So maybe here I can get 70 coins by robbing some stuff that was unexpected. By robbing some stuff in the left tree, and by robbing some stuff in the right tree, I can get, say, 20 coins. And there is some value in the root node, maybe 5. Using this info, can we tell what's the total amount we can rob? If yes, then great, problem is solved, because just DFS for this node, representing the whole tree, it will return this value we compute. The thing here is, we cannot say what's the value we can rob. You might guess, oh, maybe it's 70 plus 20 plus 5. But it isn't. Maybe 70 uses this node here. There is also a second incorrect idea. Before that, did I actually give you the link? Oh, I did, right? Link. Cool. Another idea you might have is that not only we will return what's the number of coins we get, so the amount of money, but also after the comma we will get, so a pair, true or false, whether we hit this guy. So direct child of the next node. In other words, that's the root of this subtree. 70, true, it means that it's optimal for this subtree to choose some subset of nodes. None two of them are neighbors, and one of them is the root, the highest node in this subtree, and then in total we will get 70. That's the most we can get. Maybe on the right we do the same thing, and here it turns out that's false. Can we from this figure out how much we can earn in total? Well, yes, we can figure out that here it's 70 plus 20 is equal to 90. We cannot get 5 from this node because we know this is true, so we know that this child was used. The thing is, we don't really know if it's optimal. I will give you two reasons for that. One is that, well, what if this guy here is small? What if there was only one here, or 2 or 4? This is 1, and the remaining 69 we had here. Then it's better to swap 1 to this 5. Or maybe better. Maybe then this 5 will later be an issue because his parent is actually 100. That's one thing. The other is that maybe the situation is even more complicated. So this, depending on this value and depending on what happens later, we don't know if it's worth it to make below some trade-offs here and there. Because after you're done fixing nodes here in the subtree, there are two things that are in any way important when we make further choices up. One is what's the total amount of money we got here, and the other is whether this guy was taken or not. And maybe it's very important for us not to take this guy because this value is big, or maybe it's actually doesn't matter because we will not even take this one because his parent is big, or maybe because his other child, the right child here, is very big and it's good to take. And that's only, like, we are scratching the surface here. The situation might be more complicated. It might be a little bit like domino, where, well, this is 5, this is 6, so neither of them matters, but then there is something here, and here there is 100. This 100 will mean that this guy is not taken, so 6 can be taken, and 5 will not be taken. The situation can be very complicated. And you can watch on YouTube my dynamic programming lecture to know that for DP, there is always this question, what's important so far? Or after we make some choices, usually for prefix of a sequence or subtree of a tree, then what information is needed so we could actually make some further choices. For a subtree, there are two pieces of information. One is the total amount of money we get, and the other is whether we get we use the topmost. So root of that subtree. This is false or true. Money is something we maximize, so it will be value of dp, and whenever we use the root will be dimension of dp. And also it's important at what vertex, what node I am, to distinguish situation here versus there. So if I tell you that I'm at node 5, I didn't use this node, but maybe some children, and I got so far 70 money, 70 coins, it's enough for me to continue up. And yeah, money is something we maximize. I will have int dp of node and 1 or 0 for every node, and for every information whether I want to take root of this subtree or not, I will store the maximum amount of money I can get. Or in other words, it means that for every node it will return two values. It won't be 70, true. It will be something like 70, let's say 66. One is value if we also take this guy, the root of this subtree, and the other is value if we don't. This is how we figure this out. Every node in this DFS, it should return two values. Max amount we get if we also rob this last node, and if we don't. I don't claim that first number will be bigger than second, doesn't matter. But using those, I can actually compute dp for the parent node. Let's say that this one returned to us 20, 20. Maybe here, no matter if we want to take this one or not, we got the same value. Actually, we will get some ties by coincidence, say 19. Then what we should say at this, at 5. Either we will get 5, and then from both children we need to get the value if we don't take this child. Here, 66 from left and 19 from right. This is what happens if we take 5. And then if we don't take 5, then from the left we take 70, and from the right we take 20. And that's what I return. I don't want to bother computing this. Well, whatever, okay. 65 plus 20, 85, that's 90, 90. I think it's a coincidence here that we got a tie. If this instead of 5 was 8, then this would be 8, and we would get 93 instead of 90. That's the solution I will implement. There is an alternative solution where you look at grandchildren instead of children, but I think this one is simpler. I will write down the main thing we got from this. Node will return a pair, and that's max money if we took this node too. Max money after choosing nodes from this subtree of this node, and comma max money if we don't take this node. But we are allowed to take anything below him. This returns a pair, so I will have here a separate function called DFS. And if this is null, then 0, 0. Otherwise, there is left and right. DFS of root left. This might be our 70, 66 that was in the drawing, and the other pair might be 20, 19. And then what do I return? A pair where first value is what if I take this node, that's root value plus left second and right second. Second values are those that are, if I don't take those, I'm not allowed to take children. otherwise I don't take root value. And you might say that then I take left first plus right first. That's almost correct. It would mean that from the left I get 70, from right 20. It means that I take this node. But that would mean I'm forced to take this node. Instead, I want to say I can take this node, but I don't have to. So I take maximum of 70 and 66. If I don't take 5, right, if I don't take this node, then in this subtree, I just want maximum value. I don't care if my child was taken or not. By my child, I mean this. So here it's max of left first, left second. This is what most I can get from left child. Same from right. And that's it. Shouldn't we take the max of this and that? Not really. So Rupin, Derek, you're almost correct. But with this max that you wrote, you would say that either we take left child and something below, and right child and something below, that's 70 plus 20, or we are forbidden to take this child, so 66, and we are forbidden to take this one, and then we take 19. But we can have any mix, like 70 plus 19 is good. And we can make even examples. An exact example where your code would fail is something like, say 5, 70, 6, and 20. For this tree, the value returned by this guy will be 70, 0, and for this one, it will be 6 if I take it, 20 if I don't. Now when merging those two, it's best to take 70 plus 20. For left child, indeed, I take him. For right child, if I don't take 5, then I want to take just maximum out of this. So 20 is better. I don't care about taking this guy. It's not that I need to do it. Hence, this kind of maximum, not the one that Rupin there wrote. But that was very close. DFS of root, and now we return the maximum of two values. Because we can take the root, we don't need to. This will not compile, obviously. Maybe this should be a comment. Today we are only discussing the problem and not submitting them? No. What's wrong? Value. I didn't even read the description of what the struct is. Val. And that's the only place? Yes, that's the only place. I always have the same strategy that I implement the problem if it's interesting enough. The previous problem, it had a tedious first part. And I know that I already did that in some other stream, more than once I think. So I didn't want to spend half an hour on that. Accepted, and as I said, there is an alternative solution. It's something involving grandchildren, where if you take a node, then you know that you need to skip children, so you can jump directly to grandchildren, and you can grab their DP values, so what's the biggest in that subtree. So DP at a node is my value plus the sum over my grandchildren, something like that. If I need to take this, I mean sum and DP values of grandchildren. Every grandchild should already know what's the max money you can get by taking everything there. And if you don't take a vertex, then it's just the sum of two children. Startup. I don't think I will ever make a startup, as you know, with employees and stuff. I might have a course for algorithms. That's it. That's the most startup I can do. Right. House robber done. If you ever get bored, can you hack scammers like Kitboga? Sadly, I know nothing about security. Close to nothing. So let Kit Boga do his thing. He's amazing at it, but also he's a great entertainer. Up for drawing, one node. This thing, this is one node. It's a Windows app. Can you do this? Blindly I can say I can. Any suggestions with some short description of what the problem you're suggesting is about? How do I access the last LeetCode? Like that. Oh, so this was the hardest problem. Minimum cost to change the final value of expression. I saw that problem, by the way, before. I thought that was on LeetCode, maybe not. But I would guess that you will get fastest time by copy-pasting something. Maybe also Python has some useful library for that. I don't know. It took the winner around 14 minutes, we can guess, to solve the last problem. Maybe he already worked on the second last problem. If this was just 4 minutes for the last problem, I'm impressed. But I think that's either copy-paste or using some library. How do I access an editorial? Maybe I can get to problems. This. No solution. Discuss. It's that easy to handle the input recursively? Okay. I thought it's more complicated. Yeah, I thought it's that complicated. Oh, maybe still shorter than I thought. Opening bracket, closing bracket, get from the... But don't we distinguish operations? What is happening here? Is this the full code? What do I do for a living? I teach for a living. Actually, in the future, the stream like today's one, I'm going to have monetized in some kind of way. I need a sponsor that, if I get at least $100 per such a stream for an ad, or ads, then I can live off of it. If you click on the blue icon, you can see their solution. Oh, I should have looked at the chat. Do you plan to solve any Polish Olympiad problems? I guess I should, because I have the advantage over other YouTubers, streamers, that I can access an editorial, because editorials are in Polish. But also I'm aware that much fewer? How do you say much fewer? Many fewer? Many fewer people will watch it, while something like LeetCode is much more accessible. I'm not going to do Polish Olympiad this month, for example. A School of Algorithms and Competitive Programming. What is a school? If you mean that I can teach groups or something like that, then yeah, sure I can. I wanted to here click this. That's a lot of code. Not impossible, but that's a lot. I think that here at least some parts must be copy-pasted. Or maybe he started doing that before solving Q3. Did I get 3 to 4 students for teaching? You mean the groups of 3 students? I didn't yet handle that fully. The lessons didn't start yet. I still need to answer some emails, match students into groups. I have this thought now that in order to actually match the skills of participants properly, I should make some kind of interview for them. So I will be back to solving your problems in like 3 minutes. There are services like Calendly or SuperPeer, maybe used one of them. I think Calendly is much bigger, where in particular they allow you a payment. So if somebody wants my group lessons, and it's really hard for me to handle that just via emails, because many people say that they want a lesson and they then don't follow on that. A month or maybe 2 months ago, I wanted to start 15-person group lessons. They were supposed to be quite cheap, like $10 per lesson, and I got in total more than 20 candidates for like 2 difficulties. Then I said what's the date, like what's the payment method, and only 2 people paid in like 3 days. So yeah, I need to change this to pay first and then talk, something like that. So my current idea, you can say if you think it's a good one, is that I will set up an account on, let's say, Calendly, where you can book a 30 minutes meeting with me, and it will be paid, not to waste my time, because there's so many people say they want classes and they don't pay. It will be a paid 30 minutes meeting. In particular, it will be an interview where I would evaluate their skills to see if they are a good match for some difficulty group. The disadvantage is that you pay for something and maybe you will be unhappy, not sure, obvious. The advantage is that I don't waste my time, and I think that's more important. Scalar.com. Why do you think they pay a lot? Scalar is what's behind an academy, right? I heard bad opinions about that coach of sponsor. Sarora, I saw your comment. Stop spamming, stop repeating. When I do something, I don't answer unrelated comments. 10 lesson plan subscription, but that's not about it. I wanted to have like a situation where you pay for multiple lessons. It was supposed to be for a full month, so let's say 4 lessons, you'd pay $40 or something. But still, people kept asking questions, wanted to say, yeah, I want a spot, and then they didn't pay. Then I cannot organize a class. I cannot decide, yeah, I have enough people, we can start in 1 week, because I don't know if people are willing to really take those lessons. Pre-recorded paid lectures? Yeah, I can make a course. I don't want to. Stream on YouTube and chat on Twitch? Well, stream is on both. I have a reason to have a chat only on Twitch. It used to be on both websites. YouTube was more spammy. Pay first is better for me, because otherwise, really, I wasted so much time in May for those group lessons, and they didn't even start. Really, out of more than 20 people, only 2 of them paid. So I wasted many hours on that. Got nothing. You got nothing. So as I said, I'm going to set up an account on Calendly or this other website, SuperPeer, and it will be like, I don't know, 30 minutes, $30, something. They don't. That's anyway a one-time fee. All right, back to solving problems. Somebody suggested this one, and it's from today, so let's see. Magic square, every row, column, and both diagonal sums are all equal. They do not need to be distinct. Find the largest magic square. Limits are quite low, so I think we will do a brute force, won't we? Let's think. Here it's hard to say the complexity of the full algorithm in your head. So let's write down some pseudocode. If I want to iterate over every square, I need to iterate over the top left corner. So I will have a for loop over starting row, over starting column, and that will be one cell already. Then over size of that magic square. Now I have a candidate for a square. Already this is 50 cubic. Grid size is up to 50, so it's 50 times 50 times 50. And what's inside? I need to verify if this is indeed a magic square. If I do it brutally, so for every column go through all the elements to sum them up, same for rows, same for 2 diagonals. Well, diagonals are the easiest because there are only 2 of them. The most naive solution will be size square, or it will be O of size if we use prefix sums. Then with prefix sums in constant time you can verify every row and every column. Then the whole thing is size of the grid squared. Let's call it, not squared, fourth. Let's say that size of the grid is G. G is up to 50. Then it's 50 times 50 times 50 times 50. And I think that this will be a fine solution. We can improve this part maybe with some kind of binary search. Not really. If there is a magic square of size 10, doesn't mean that there will be a something of size 9 and 11. So it's not that starting from some size there will be a magic square of that size. Diagonal sums have to be equal. So you can do w squared times h. Loop start column, end column, maintain row sums. Loop start row, you know the sum you need to, so no end row. Yeah, rows and columns need to be equal to. Okay, I'm glad, Manga, that we got to an understanding that what he said doesn't make sense. For diagonals, it doesn't really matter if I use prefix sums. So to simplify my code, I will not do that. But yeah, for every diagonal, you could also have prefix sums. If it was true that I will write this down because this is very important in general. You need to understand when not to use binary search. If this was true, that if there's magic square of size, say 7, then there's also magic square of size 6, 5, 4, and so on. So if they form an interval, like if there is answer of size 7, there is an answer of size 6, and then also 5, and so on. If it's like that, then you can binary search. And if you check, oh, there is a magic squares of size 4, then you need to only go higher. If there isn't a magic square of size 9, you need to only go lower. But if this is not true, then it might happen that you check if there is a magic square of size 9. No, there isn't. But maybe there is something of size 10. So you cannot go low in that binary search. So binary search isn't possible here. Then also we cannot iterate increasingly over size. There is some other trick, just like binary search, where we would get rid of this this part, and it would be g cubic instead of g4. So I don't see how to speed this up further. Maybe with like moving with this square by 1 to the left. I don't think that's needed. Just we can think about it. So when you check some square, let's say this green one, what we can do is later we can move by 1 to the right, and we can notice that the columns are almost the same. Only one column changes between those two situations. For rows it's a bit different, sure, but maybe if I check here if all the columns have the same sum, then I move here by the right to the right by 1, I still know if all the columns are the same. So I'm here and I write down if columns are the same, or I actually compute the sum in each column. 10, 11 is 1 plus 5 plus 5, and here 9. If I move by 1, I don't really need to repeat my computations. Sure, I can say what's the value here. So maybe I will do this. Let's handle at once all squares of this height. So it will be this square, this one, and this one. For every column, using prefix sums, I will know what's the sum of values. Those three sum up to 10, 11, 9, 11, 14, and 12. Of course, here nothing is the same. And here I need to detect if there are 3 in a row with same sum. And that's then some candidate for a square. I will later do the same for rows, of course. Let's see this working for those 3 columns, those 3 rows. The sum here is 4, then here it's 12, 12, 12, and here 10. Which means that if I look at this square, columns have the same sum. And I think that we can use this to get down from size of the grid 4 down to size of the grid cubic. And maybe I will try to do it at the end of the stream. Like with this, for every square I will say if its columns are the same, and if yes, then what's the value for every column sum. Then I will do the same for all the rows. Obviously I will not want to copy paste code and modify it. I will just flip the grid, like mirror, like via mirror, and we'll apply the same algorithm. then for every square I will know if all columns are the same. If yes, what's the sum in every column? Are all rows the same? If yes, what's the sum in every column, in every row? I will compare those two values, and then I need to handle diagonals. But there are only two diagonals, not a linear number of them. And for each of g cubic candidates for squares, I need to handle it in constant time, but I will already know via this pre-processing, and that should be g cubic total. If rows and columns are proper, then in constant time I need to handle diagonals, and that can be done only with prefix sums or some kind of sliding window. If you know the sum, if you know the sum of three values here, then you can move this thing by one like this in constant time. So sliding window or prefix sums. What if there are two rows of column sums of the same value? Oh, for each of them I need to, in this sequence of sums, I need to detect every interval of three consecutive equal values. Like in your example, here, let's say that I consider size 3. I need to detect that this is a valid candidate, this is a valid candidate. Even more, maybe this is again 12, and maybe this is also 12. Then also this is a valid candidate, and this one. Assuming that this is the same as this green sequence. It's for some fixed height. For every column, I calculated the sum of values. But of course, this speed up, we get into competitive programming territory. It's not really a good interview question, I would say. At least I wouldn't ask candidates during an interview. Let's for starters implement the brute force, and then we'll see if it's reasonable to speed this up during the stream. Magic rectangles, you mean those with distinct values? Well, then we would need to handle distinct values in some way. In particular, we can of course do it with brute force, where for every square we just iterate through everything. Maybe it can be done faster. I don't know. Would need to think about it. You know, I think those what-ifs are in general a waste of time. So let me go on a tangent, and then I will be back to solving a problem. There a lot of people ask, there is some problem in LeetCode or in a contest in Codeforces, and they ask, what if values, let's say, could be equal? So what if there can be ties? And say there is some problem, values are guaranteed to be distinct, and it makes the problem easier. And well, what's the purpose of asking such questions? Well, maybe that version of a problem is also solvable, and you are curious how to solve it. But here's the thing, you don't know the difficulty, and it's not necessarily solvable. So it's possible that you're wasting your time, and it's possible that you're not, and maybe this is reasonable. Maybe this is on your level, and indeed you should think about how to solve it. You will get it or not. Maybe somebody else will give you a hint, and then you will solve it. But then the best case scenario is indeed that it's solvable and it's on your level. You will be able to comprehend the solution. So the best scenario is that it's just like a standard problem. Instead of asking this question, you can as well just open completely different problem and solve it. Then you know it's solvable, and you can even submit to see that indeed you got it correct. But there is also a case where this is not solvable and you wasted your time. So if you're not very experienced, then don't ask such questions. Maybe I'm the one in wrong here, and I'm like killing your spirit and your curiosity. But at least be aware that possibly you're not doing anything, like you're not moving forward by asking questions like this one. If you're a problem setter, then you should ask those questions, because this is how you come up with new problems. So same here. What if here the magic square has distinct values? You can think about it and you will waste time or not. Same for me. I can think about it. Maybe it's solvable, maybe not. Maybe it's solvable, but I will not be able to come up with a solution in 10 minutes. So, you know, if best case is just like a normal problem and worst case is waste of time, let's not do it. I think you shouldn't ask those questions. That's my opinion. And I'm not saying here that you just cannot. You can. But I prefer to solve problems that for sure are solvable and they are reasonable. Wait, need to answer. At today's LeetCode regular contest? No, I'm solving now interview problems. So I don't know if there is a possibility to solve this in cubic time for distinct values, but for now I will focus on this version because I know it's solvable. Right, brute force. There is height of the grid. Actually, let's call it height, it will be easier for everybody to understand. Width. On purpose I'm using uppercase because that will be a constant, something I don't change. I iterate over what will be the starting row and starting column. Let's call it row 0. On the other hand, it's not a good name, because later if you use call, it's very easy to mistype something. Use call instead of call 0, just miss one character, it will compile, but it will work terribly. Anyway, I don't want to bother writing the whole starting row. For size. Now what can be the size? I think I will here iterate infinitely without any limit, but here inside I can compute what's the last row of this square and what's the last column, and if they exceed the grid then I can break. Columns are up to height -1, width -1. Rows are up to height -1. So in that case break, and this will it will handle this for loop. It will finish it whenever it should finish. Hi Timothy. This layout is better. You mean the fact that in LeetCode it's not left, right, and instead this? I don't know. For a stream, actually, I would prefer to always display the statement for people who are just joining now. And for those who are joining now, we are given a grid and we need to find biggest size magic square inside. Magic square should have the same sum in every row, column, and diagonal, but we don't care about distinct values. There can be ties, we don't care. Go with descending. Why? Oh, wait. Size is that? Like here, I don't want to consider size height -1. Oh, I know what you're talking about. You want to say that Here we should iterate over size from biggest possible and down, so with size minus minus, and whenever we see size equal to 5, size equal to 50, we shouldn't bother checking smaller. I agree that it's better for running time in some tests, but there will be some worst cases where it doesn't help. And then I would even say it's dangerous in competitive programming if we do something like this, because you might generate a max test and it will be very fast, but it's only fast because it's not a good test. So, you know, sometimes I dislike such speedups, but yes, it's perfectly fine if you do that. If the first for loop is over size from biggest and you stop whenever you see any magic square. You will even avoid extra variable, because here obviously I need to store the answer, and whenever I see something being a magic square, I will maximize answer with that value. So your method is shorter in terms of code. Just, you know, time complexity is the same. For the worst case, the running time will be exactly the same. So I will not bother. How are we checking the diagonal? Well, we can iterate over the diagonal. Here goes the brute force. Let's say we indeed iterate over diagonal. That's grid of row 0, col 0 would be the top left cell, and I need to add I. And let this be reference sum. Everything should be equal to that. Or let's call it diagonal 1. What about diagonal 2? Diagonal 2 plus equal. From the same row, I will take col last minus I. Col last is the last column in this square, and minus I will move backwards. I guess already here we can do this, though we could do it at the end as well. Diagonal 2, continue, because that's a bad square already. If diagonals are the same, then for every row and for every column I need to do something. Let's start with, say, rows. If I use row last, I should have used row first. It would be nicer. Actually, let me change that. Row first. More typing, but I guess then, yeah, a lot more typing. Row first, then this will be col first, right? Column, the first column in the square. I'm sure I will miss something and will get compilation error. Okay, for every row, brute force version. Column first, column second, not second, last. Rid of row column. If that's not diagonal 1, then put this. And there is a flag. This flag will say that it's indeed, say, is magic. That's more meaningful flag. Same for columns. Here it's not complicated, so I will not bother, you know, flipping the whole grid to avoid the similar code, because flipping itself would be more complicated. For every column in this range. Also, before that, I could continue if is magic is false. Maybe I will do that. Later I'm going to replace this with prefix sums. If this, then we indeed got magic square. If your code doesn't work, then this would be a good place to print some debug information, like print what's the top left corner and what size of the square. Gold topcoder problems. What's going on? We are complaining about topcoder. How do we calculate the sum of n by n magic square? Well, you can use arithmetic series for that. There is a formula, but here values are not distinct, so we will not compute the sum of everything. Diagonal 2 doesn't exist. Some typo? Yeah, lack of L. LeetCode or topcoder to Iowa aspirants? Neither. Topcoder currently sucks, sadly. Interface is bad, people often complain about problem quality, and LeetCode isn't about competitive programming at all. Use AddCoder and CodeForces. And CodeJeff. Those three. So this might get time limit exceeded. Well, it didn't. Oh, interesting. I wonder if it will get time limit exceeded for a strong test. Let me do something. Grid is this of size 50 by 50, full of values, say 7. Yep, let's test this for the sample test. That was 260 milliseconds. They usually have time limit like a second or two, but that's for multiple test cases. I'm quite sure that if they had strong tests, then my code would get time limit exceeded. My code continues already here, when two diagonals are not same. I bet that if I move this here, I will actually get time limit exceeded. Because now my code will not finish early. Submit. Time limit exceeded? No. Why? Well, this is fifth. This doesn't use prefix sums. It's g to fifth power. And I understand that the constant factor is low because the for loops, they are not like full. It's g to fifth power divided by 20 or so. But I thought that they require something faster. So it's this, but let's think. For a random cell here, sizes are up to around half of that, and then iterating over this, iterating over that, iterating, yeah, this is size squared. So let's say on average size is grid squared, maybe even lower. This is that, sorry, grid size half. Then here we have that squared. I would estimate this as, I guess it's something like that, actually. So sure, it's fast, but LeetCode uses multiple test cases. So it's not, time limit is not for one test case. And I often in the past got time limit exceeded. My solution was fast enough for a single test case, but there were like tens of them. And it makes LeetCode not really competitive programming friendly because you need to guess if your solution is fast enough. Okay, let's speed this up. We had g to fifth power. Now we want g to fourth power. And for that, I will use prefix sums or sliding window, but prefix sums will be easier. This piece of code, it's supposed to get the sum of values in a column. Not in a row. In a row, I want to get the sum of numbers from this position to this one. I will say that this is horizontal sum up to row column last. minus horizontal sum, or just horizontal, let's call it. This will be prefix sum based on this row. Column first. And here I can say -1. Yeah, let's do that. And this ternary operator to avoid out of bounds if column first is 0. Now let's compute this as preprocessing. Horizontal here is same as horizontal on the cell to the left plus the value here. Same trick to avoid out of bounds error. For non-C++ users, this means if column is not 0, then do this, otherwise that. So I just get 0 as the previous value. Let's check if this works, and then I will add the same for columns, but this should already be faster. Accepted. More details. 344 milliseconds, and hopefully it will be faster after I replace this. There is also some parts here where I don't use cache optimally, but I will not bother optimizing that. In places like Codeforces, you can for sure read more about cache and actually how you should arrange your for loops and dimensions in multidimensional arrays to take advantage of cache. Here we go, row first, if that otherwise 0. And we need to, of course, compute this. I think done. And is the time any better? Yeah, 140 milliseconds. That's reasonable. Did I read Maxim's blog on counting primes? I think in my favorites there is something like that here. This is my... Oh, it's very hard to read. Yeah, Codeforces doesn't work well with dark mode. This is my list of blogs to read. And I'm quite sure that somewhere here there is something about counting primes. Yeah, here you go. So this is a blog from 5 years ago, titled "Counting Divisors of a Number in n to 1/3." Is that the same as Maxim's blog now? I think it disappeared from the recent actions. Is it the same? Counting primes? Oh no, counting divisors. Oh. Oh. Okay, then that's different. Yeah, I didn't read Maxim's blog. Didn't read Maxim's blog because I thought that I still have this one as to do, and the new one is about the same thing. I didn't read the title carefully. Yeah, so we have g to 4th power, and what's the time? What's that time? I cannot speak. 1:35 minutes. Maybe I can try this to get G cubic. I don't know if I want to. Which algorithms I learned for problems level C and D? Whatever encounters in those. So solve problems C and D in code forces and read editorials, and you will learn everything needed for those problems. Find the job of software developer in 4 months. I can help you with that. Programming. Can I get a job in 3 months? 3 seems to be more round number, but here we go. I think you can Google something like that and we'll get an answer. Definitely it's possible. Exclusively programming? Probably not. No way. It's so funny that there are 3 answers. Like always the first sentence says what they think, and it's a completely different answer. Probably not, definitely possible, and no way. I would lean towards probably not. Yes, there are bootcamps, programming bootcamps, but they are quite time consuming. I would expect this to be more like 8 hours a day. And believe me or not, but you will be a shitty programmer. Now, for any kind of job, you're asking basically, can I become an X by spending less time than others who learned for that job? Well, maybe you will get a job, but you will be worse than others in doing that job. Sorry. But I think if in some hypothetical scenario where you're gravely sick or in your family there is somebody like that, and in 1 year you need to get some cash for an operation, it's very expensive, then your best bet, other than illegal activities, is to spend all your time to become a programmer, assuming that you have any kind of talent for that. For sure, some people cannot even become a programmer in 5 years. Like, it's not for everybody. But then I would try to become a programmer in several months, get a full-time job, and then also your credit score will be better, maybe. Breaking Bad? I didn't watch Breaking Bad, so no spoilers. Actually, I knew that part about Breaking Bad. Yeah, indeed, it's about that. So you're saying Breaking Bad is about a programmer, gravely sick programmer. Vibe, stop asking questions like that. Solve C problems, then he will be able to solve C problems. That's it. I don't know. Do we try this? So for every height, we do that. I'm going to watch Breaking Bad. Yeah. Yeah, let's do it. This will be the last thing for today. So if you watched this stream to learn something, to get better at interviews, I guess goodbye. The stream is over for you. And now I will do something tedious and unpleasant. I will try to solve this in better time complexity. Instead of G fourth, we will get G to third power. And for this, a reminder of what's my plan. For every stripe, so for every interval of rows, let's say for those 3 consecutive rows, I will go through, for every column, I will want to know what's the sum in that column. I will write down those sums. Then I will want to know what are intervals now of consecutive 3 elements that are equal, like here 3 consecutive 12s. Then this is a candidate for a magic square. I will remember that this is a good magic square in terms of columns, and this is the sum. Upload the Discord banner? I don't want to. Yeah, that's the plan. Then do the same for columns, I mean for rows instead of columns. I'm not sure if I will mirror the grid, or maybe it's better to instead copy paste the code. Did I see problem 4? Yes, at the beginning of the stream I did problem 4. Later on YouTube you can watch, rewatch, but I didn't implement, because I thought that the part about implementing a recursive solution will be too tedious. Right, now row first, row last, now for every column I want to know the sum of this short stripe. Not grid, that's vertical, right? Yeah, vertical. One of words that I don't really know in English and always I need to think for a second or two is vertical versus horizontal. I never remember which one is which, and I need to think that yeah, horizontal is the one like that and vertical is the other one. I'm never sure, like, without thinking intuitively. There are a few things like that even in Polish, like west versus east. Same thing, I need to just think about the map and am I sure which direction was which? Yeah, it takes me maybe half a second, but it's not trivial. Left and right is obvious, but west versus east isn't. Then I remember what countries are in the west. Like I remember what is the west in the map. That west is the rest of Europe and east is, let's say, Russia. Then after that I can figure out, okay, east is the right direction and west is left. For horizontal and vertical in English I need to think for a second. Yeah, it was that one. Vertical. News is the clockwise. Okay, but how do you remember clockwise versus counterclockwise? Maybe you can remember, okay, clockwise was the one with news, east was to the right, so clockwise is like that. I understand that clockwise is like the clock works, but same thing. It's not immediate for me to, when you say clockwise, I don't, without thinking, know what direction it is. Get confused by row and column? Why? In grids there are rows and columns. What can be less confusing? Think about it when we say Earth spins from west to east. Yeah. I guess. What am I doing? I was here. For every stripe of rows, for every column I know it's sum. Vertical of row first minus one column. And this is an example where this is not cache friendly because you iterate over column. Oh no, sorry, this is cache friendly because column is the second dimension. But the other case will be not cache friendly. Human benchmark test. I did that. I think I did that during a stream. Maybe one day I can make it. Maybe tomorrow or next weekend. Right now. Let's call it sums, I don't know. I think for running time speed, I'm able to do it in constant space, or at least without this. First, let's do that. Okay, now I need intervals of size consecutive equal values. And I can do it kind of with dp. sums of col is equal sums of col minus 1 equal plus plus. I count blocks of sizes of blocks of equal elements, else nothing. No, else count is 0. 1. And after that, if count equal is at least size, then this is a possible end of a magic square. So is magic of, or maybe like that, if that's smaller, then it's magic of row first. Minus size plus 1 is false. A magic square cannot start there. If the magic square ends at column, then this will be the first column. So this will be top left corner. And this makes sense to check only if column is at least size minus 1, because then it's a possible spot for the end of a magic square. I think also I need to remember what's the sum. Let's do it like that. Column sum. Okay, this is a bad name. Rough. Magic requirement. Is this how you spell it? Requirement? Yeah. Now, if I see that columns are equal, I save the value that should be there. And later diagonals and rows I will need to compare to this. Sorry, this is too hard of a word for me. Magic rec. Magic sum. Oh, magic sum is great. Another very complicated word is threshold. It's something that often is needed in code, but I prefer to skip it because I'm not sure how to spell it. Play PC games to relax? I don't know, sometimes. Not sure if you can code so much in an interview. Yeah, I warned all of you before starting this part of the code. I already got accepted here. We got this complexity, but now we're moving to something faster and I guess not expected by author of this problem. It's not an interview problem anymore. We're doing something extra. It's just for fun or for pain, I don't know. Magic sum, height by width. By default filled with zeros? Let's say so. Can there be zeros here? No. Every sum will be positive if we mark it like that. Okay, then we need to do the same for columns. If I flip the grid to just, I can do it. I can here make a for loop of size 2. Now shift of all of this to the right. Repeat this algorithm twice, just between the repetitions flip the grid, so columns would become rows. But I think there's too much row, there's too much work for that. Or is it? Yeah, let's be nice, let's do that. So I will indeed do that. This should be repeated. Oh, wait. Magic sum isn't just for every top left corner, it should be for every size separately. This is wrong right now. Either I need to add third dimension to this, so for every candidate for a square, so every top left corner along with the size, I would know if it's a good magic square or not. But I'm not here improving the time complexity only to mess up the space complexity. So I think instead I will do what somebody suggested a long time ago. I will iterate over size. It's not really to speed up the running time and to stop whenever I have the biggest size, and I already found, let's say, magic squares of size 15, so I don't check lower sizes. But it's for the sake of space complexity. For every size. Let's go backwards. Then answer will not be needed. Horizontal will kind of flip with vertical. I need to move this inside too. I think I will not need horizontal. Right? For now, let's leave it. Okay, what happens now? I will first try magic squares of size height, not height, minimum of height and width. Go downwards. I have a magic sum. Then twice I will repeat something, and between the repetitions I will flip the grid. Compute the, I think, only vertical stripes, vertical prefix sums. For every row first. Row last is, I know what it must be. Now this can just be true. This condition doesn't matter. This one will break eventually. Size I know. For every column, do this. Okay, I think we're good here. But after that, we need to flip stuff. Flip / mirror. The problem is crazy. This solution is crazy. 3 nested for loops. I think previously in the slower solution we had 4. Because, yeah, 1, 2, 3, 4. But the first 2 are just to iterate over top left corner. So they are trivial. Like, you need them to start to anything. By the way, to easily, let's say, find a rectangle in a grid where the sum is equal to the target value, that will require 6 for loops. Because you iterate over top left corner, that's 2 for loops, bottom right corner, another 2 for loops, and then you need to iterate over this rectangle, this subgrid. That's 6 for loops. It can be done faster, but that's not the point. If for loops are easy to understand, like here, those two they just describe top left corner, then it's not that scary. At least this shouldn't be. Okay, flip. What do we flip? Only the grid. This should allow us to swap rows with columns. No, it cannot be a constant, obviously. for every size we will do something that, sure. The final running time will be quite slow because I do g-cubic multiple times, like here with copying memory. That will not be very fast. And what else? I remember this between repetitions. That's bad because I did that for rows, then for columns it should maybe also be swapped. Here, if repetition is 0, then do that. Else, if repetition is 1, then old value is magic sum of the other way around. If old value is 0, then it means this is bad. So only if it's not 0 and it's equal to sums of column, then this is a good square. Last thing to check is diagonals. Right now I will do it with brute force, and later we'll do it faster. So the old value, it is, if that's non-zero, that is it's information that every column in this magic square was the same and it was equal to this old value. Now if it's equal to sums col, to now the sum in every column after flipping the grid, it means that rows and columns are the same. Diagonals can be checked in constant time if we have proper prefix sums. But first, as a warm-up, let's do it with in linear time. Grid of what? Row first plus I, column minus I. Column is the last column. That's the end. Diagonal 2. But what's call first? This is call first. And now, if old value is equal to diagonal 1 and it's equal to diagonal 2, done. Easy and beautiful code, sure. And with this I mean, what an ugly mess. Compilation error, sure, why not? Line 38. Line 80. I claim that we will never get here. Assert false kind of guarantees that. What? Assert is not included, or what's happening? Oh, I'm not inside a function. Why don't you write educational division to rounds? They are easy. Assertion false failed. That's bad. And this is sample test. It is. So I did not even detect that this is good for like 1 by 1 even. I didn't detect as a proper magic square. So there is a bug. We need to find it. For every size decreasingly. There is this two-dimensional array filled with zeros. Twice we will repeat something up to here. And we create vertical prefix sums. Then for every first row, I first iterated over size, so I know until where it goes. It cannot exceed height, obviously. For every column, I want to know the sum in that column. This part previously worked, so it should be good. No, it didn't. That's the first time I'm using it. Never mind. Row last column minus row first minus 1 column. Yeah, okay, this should be the sum of that short stripe. If this is not the very first column and we have an equal value, then increase the count of equal values. What's this? If that's not true, then count equal cannot exceed size, so I can remove this condition. I can even say assert that this is true. If I detected that so far already I had 5 equal numbers, then for sure the column is at least 4. From 0 to 4, then we have 5. It's not that for column 1 I will detect that I had so far 5 equal values. Column first, sure, because column is the last one. For the first iteration of this, I mark that this is a good start. This is a good candidate for top left corner. Otherwise, magic sum of the other way around. Yeah. If old value is equal to the current sums. Maybe this is wrong. First plus I. This is last column. This is first column. Looks good. Why is this not good even for size equal to 1? Then flip. Create a new grid width by height instead of height by width. Iterate over everything. And this assign to call row. Looks good to me. Let's analyze what can happen for size equal to 1. Filled with zeros. I assume that this is correct because I used prefix sums already in that accepted code, the slower one. For every row first. This is same as row first. This is not true. When row first is 0, this row last is also 0. There is sums. Count equal cannot even be smaller than that. If repetition is 0, then we remember like this. Magic sum of 0, 0 will be this sum, so just a single value. Otherwise we have this. I want some printing. If size is 1 and row first is 0 and that's it. Let's print old value and column for starters. Old value is always 0. That's bad. Also, what's the current rep? Today that command doesn't work, sorry. For repetition equal to 0, I didn't find anything. Well, that's here. Magic sum. Rep sums of call. Now we will have more information. Why is this 0? Shouldn't be. Should be 7. which means that this line is wrong. It is wrong. This word should be grid. My array vertical is just full zeros. This line for horizontal was correct, but here, like to compute vertical, I didn't even use values from grid. Free. All right. So you see, printing is still the best method to debug. Accept that. Still, we are G4 because of diagonals. But we can speed this up. Now that we have a very good time complexity, I would like to be faster than others. But creating this multiple times, it will not help our cause. Explain this approach again. Well, I can do it once, I guess. Here's the thing. Ignore the red frame. It wasn't drawn by me. It's from the statement. For every interval of rows, let's say for this one. For every column, I can use prefix sums to efficiently compute the sum of values. Here it's 3, then 10, and so on. 3, 10, 5, 9, 6. Then, whenever I see two consecutive equal values, let's say those two are equal. They are not, but if they were, it means that the sum of those columns is the same. So this is a candidate for a magic square. And at this top left corner, I would mark, hey, you are a candidate for a magic square, and the sum in every column was, let's say, 5. This is what would happen if here we had 5. Like maybe this is 2. Then we had 2 5s here in a row, so I would say, hey, this magic square this square is indeed maybe magic, but we need to handle now rows. We need to check if every row has the same sum. How do we do that? I apply the same logic, just for columns. I do that by flipping the grid by 90 degrees, but well, I would look for this interval of columns, I would look at every row and would figure out, hey, here interval sum is 7, here interval sum is 7, so hey, every row is the same. So in top left corner, I would say this is good top left corner of a magic square of size 2. The sum in every row is the same and it's equal to 7. Then I would compare 7 with 5. Here it doesn't match. It doesn't match, so it's not a magic square. But if they are, then one last thing I check is diagonals. And for now I do it slowly. I just iterate over a diagonal, but I can make it faster with prefix sums. Diagonal sum is usually diagonal sum up to my top left neighbor plus cell here, but I do that only if those two values are non-zero. Then where do we use it? Here, diagonal 1 will be just, actually that's diagonal 2. Diagonal 1 will be just diag1 at here minus the row first. That's not row first, row last. Do I have row last? Yeah, we have row last. So up to the bottom right corner minus this. Same trick to avoid out of bounds. Beautiful. this goes the other direction. Yep, let's submit now. No. But it will be easy to figure out the cause of this runtime error. I just want to know. Oh, it worked here, surprising. Is it because... yeah, because of rotation. Because of a flip. It will work if I do it here inside, but it will make the code even slower. I flip height and width are the other way around, so the same cell will not exist. Try now. Accepted. I don't even know if it will be faster. I think that's slower than before, right? Because complexity is better, but tests are actually weak. They are not max tests, or rather, they are not tests with a lot of equal values. And the simple code, it stopped whenever it saw that two values are distinct. This new code of mine, it will always be g cubic, where g is size of the grid. Anyway, let's finish improving this to g cubic. But if constraints were larger, like 500 by 500, and tests were good, then my solution would pass and others would not. Yes, one last thing. If row is different than 0 and column is different than the width minus 1, then this cell exists. So we have now prefix sums over other kind of diagonals, and we can quickly ask them and in constant time get this sum. I think that's it. Just fix out of bounds here. Please work. Didn't work. Can you make the code print your own source? Well, in Linux for sure I can, because I can access the same file, so sure, it can run the bash command. Nothing interesting, to be honest. Grid, that's very stupid. Diag2. Free. $160. Much worse than before. No file system. What do you mean? Linux has a file system. Should not use file system. Well, you know, of course you can add more conditions. I don't know. I can now stop and try to think about it, but I'm busy doing something else. Is it cubic? Yeah, it is cubic, just slow, because of parts like this one. So we did it. We moved from g cubic to from g4 to g cubic, and we slowed down the program. 4 weak tests. I'm sure that for just a square 50 by 50 of equal values, where the previous program would not be faster in any way, it would not break earlier, this would be faster. You can even try, right? Do you remember what was the time I got when I tried such a max test before? because now we will have 0. Shouldn't be 0. Well, maybe it is 0. But then why is it so slow in total? Oh yeah, I see. Because because of this. So there might be a worse test for me. Won't it be worse if actually all values are different? I think it will be worse. Yeah, that will be my max test. It's interesting that the worst case for the previous code actually here works in 0 milliseconds. Rate of row count is around something. 36. I claim that this is new max time for me. 260 earlier, and was that for G4 or even slower version? I don't know. Yeah, so that's our new time. Of course, I cannot submit this because I'm overwriting the input. But that's it. We got to G-cubic. Complexity-wise, this is the best we can do. And that would be more distinguishable from slower solutions if constraints were bigger. For 50 by 50, even the first G to 5th power solution was fast enough. Not really worth it. For sure, during an interview, you wouldn't need to do it. Maybe you would get some extra points. Yes. An interviewer would be impressed if you just described this idea, I guess. But there would be no point coding it. For me, it took, what, 40 minutes? So, if that was a 45-minute interview, I wouldn't be able to code it because there is also talking. And maybe first we talk about brute force, about some other versions. So if now I coded the G-cubic version in 40 minutes, for sure I wouldn't do it, along with other things, during a 45-minute interview. 360 milliseconds to 36 isn't that big of an improvement. 360 to 0 or to 1, that would be big. And for big constraints, it's like that, where, let's say, n is up to 100,000. Now for n cubed, n squared works in, let's say, 10 seconds, and O of n works in 10 milliseconds. It's 1,000-fold improvement. Reason not to use FreeOpen on C++? I don't know. I use it sometimes. Maybe there are better, more recommended methods. Fourth problem I did at the beginning of this stream, without coding, but I discussed it. So on YouTube later you can rewatch, or on Twitch, whatever you prefer. Alright, that's it for today. Tomorrow I might make a stream after Code Forces one. There is Code Forces in the evening, it ends around this time. What's the duration? 3 hours. So it will end exactly in 24 hours from now, plus 10 minutes. Maybe I will go live then, if I participate in the contest and do well. I'm not sure. I might decide only during the contest, after I see if I perform good enough. I guess time to lose my Nutella, because my rating is 3000, exactly needed for legendary Grandmaster title. Alright you all, thank you for watching, and bye. Maybe some raid. I didn't do that for a long time. What's this? Real-time stock tracker. Oh, just tracker. That's not that interesting. Any LeetCode users here? If chat you have any suggestions, please tell me for a raid. Why use dark mode on code forces? Yeah, I don't want to use dark mode on code forces. I think that code forces looks much better in white mode, even though it's very white. But I used it just for LeetCode. I don't hear anything. But still, we found somebody doing LeetCode. So here you go. Say hi from me. Rate or host? I think rate. Yeah, done. All right, bye.